All right. So ethanol here has a density of 0.789 grams for every 1 cubic centimeter. Immediately, I'm going to write that like this. 0.789 grams equals 1 cubic centimeter. Every time that I see a density on this page, I'm going to try to write it like this. I'm actually going to do all my math in this way. I'm going to show 0.789 grams is equal to 1 cubic centimeter. That's true for ethanol, because that's the density of ethanol. Let's go to question A. What is it asking? It wants to know the mass of 225 cubic centimeters of ethanol. It wants to know something about this volume of ethanol, 225 cubic centimeters. So I'm going to line up that 225 under my other volume, right? The volume that I have here. I'm going to match units. Cubic centimeters goes under cubic centimeters. And now I can run through those questions again, right? I can ask myself, okay, is 225 bigger than or smaller than 1? It's clearly bigger than, so I'm going to ask myself, how many times bigger is it? Well, we should be able to see that it is 225 times bigger, which means that on the bottom, we have 225 times as many cubic centimeters as we do on the top. If we have 225 times as many cubic centimeters, then we should also have 225 times as many grams. So to figure out the number of grams that goes with 225 cubic centimeters, I'm going to say 0.789 grams times 225 times as many grams equals what? Let's see, 0.789 times 225. I get 177.525 grams. This is the number of grams that goes with this many cubic centimeters, 225. So I'm going to say, what is the mass of 225 cubic centimeters? Well, it is 170. Oh, that's way too light. It is 177.525 grams of ethanol. That is the mass of ethanol that goes with this volume of ethanol. Okay, great. Let's move on to B. B is asking now, what is the volume? So now it's looking for a number of milliliters. How many milliliters? Of 75 grams of ethanol. Well, we're still with ethanol, so I still want to use my same density, use my same starting point of 0.789 grams equals 1 cubic centimeter. But this time, we want to figure out how many milliliters, question mark number of milliliters. I'm going to write cubic centimeters because it's the same. Those are the same number, right? Or the same unit. And what do we know about the amount of ethanol that we're trying to find the volume of? I know its mass. I know it's 75 grams. So I'm going to put 75 grams right under my other number of grams, 0.789. And then I'm going to ask myself, is 75 bigger than or smaller than 0.789? Well, it's clearly bigger than, right? So how many times bigger is it? This might be the first time that we've encountered a problem where we can't immediately see how many times 75 is bigger than 0.789. Right? We don't know what that number is. We'll have to figure it out. But maybe we can see that it should be roughly 100 times bigger. Because let's move that decimal 2 over 78. So it's close, right? It's close to 100 times as many. Can we figure out exactly how many times it is? Exactly how many times this number goes into that number? Well, sure we can. We can do a little bit of division, right? We can say 75 divided by 0.789 equals what? Let me get my calculator. 75 divided by 0.789, which is 95.5 95.057 times greater, times bigger. Well, okay, so if this goes into that 95 times, then to get from the top to the bottom, I need to multiply by 95.06, let's say. Multiply by 95.06. We have 95.06 times as many grams on the bottom as we do on the top. And if we have 95.06 times as many grams, then we should also have 95.06 times as many cubic centimeters. So to figure out the number that goes in this question mark here, it should be 1 times 95.06. I don't need to write that math out. It's very clearly 95.06 cubic centimeters is our answer. .06 cubic centimeters is our answer. Great. That's it for ethanol, right? 4A and B, no longer dealing with ethanol. 5. What is the density of water in grams per milliliter? And it asks why. I don't really like that question. I also feel like this is more of just a knowledge question, because it's 1. It's 1 gram per milliliter. Now, maybe what this question is getting at is... No, never mind. I don't even want to go there. It's 1 gram for every 1 milliliter. That's something, I guess, that we should know. Okay, let's move on to 6. The cup is a volume widely used by cooks in the U.S. You'll probably have used a cup if you've ever made brownies or something. 1 cup is equivalent to 237 cubic centimeters. If 1 cup of olive oil has a mass of 216 grams, what is the density of olive oil in grams per cubic centimeters? Let's start here with the question. This is a good strategy. Start with what the question is. Figure out the meaning of the number that our answer is going to be, right? So if we're looking for the density of olive oil, then we know from our definition of density that the number we're looking for is the number of grams, which is equal to 1 cubic centimeter. The mass of 1 cubic centimeter. That number is the number we're looking for. Right? So let's just remember that. Okay, well, now let's look at the information that they give us here. I know that 1 cup is equivalent to 237, so I'm gonna, or 237 cubic centimeters. So I'm gonna write that like this. 1 cup equals 237 cubic centimeters. Okay, what else do we know? We also know that 1 cup of olive oil has a mass of 216 grams. Okay, so I know that for olive oil, 1 cup equals 216 grams. Okay, so I know 1 cup is equal to this many cubic centimeters and this many grams. So I can set those numbers equal to each other, right? I can say 237 cubic centimeters is equal to 216 grams. Now, this is only true for olive oil, right? Because if we have a cup of water, it would weigh differently than a cup of olive oil. But for olive oil, this is true. This many cubic centimeters is this many grams. So, okay, that's a pretty good place to start. So now I have my 2 equations, right? My 2 equal signs that I can line up. I just need to figure out how to line those up, I guess. Well, I'm going to definitely want to put I want to line up my units, right? So let's do it like 216 grams equals 237 cubic centimeters. We'll start there. And then I know we're looking for the number of grams in how many cubic centimeters? 1. 1 cubic centimeter, because we're looking for the density. We're looking for the number of grams. We're looking for the mass of 1 cubic centimeter of olive oil. So, okay. I'm going to find my question mark. I'm going to go to the opposite side of the equal sign, and I'm going to compare that number to the number above it, or below it, depending on the way that you set it up. But I'm going to ask myself, is 1 bigger than or smaller than 237? It is clearly smaller than 237. So I'm going to ask myself, okay, how many times smaller is it? What do I need to divide the top by to get to the bottom? Well, I should be able to see that I divide by 237 cubic centimeters. Sorry, divide by 237 to get from 237 to 1. So I have 1 237th as many cubic centimeters on the bottom as I do on the top, which means that I should also have, wait for it, 1 237th the number of grams. So to figure out the number that goes in this question mark, I'm going to do 216 grams divide by 1 237th the number of grams equals what? Let's get my calculator. 216 divided by 237 equals 0.911 grams. And there we go. 0.911 grams is the mass of 1 cubic centimeter. Let's make sure that we put our answer in the right unit though, right? Right now I have it in 0.911 grams, but remember it's asking us for the density in grams per cubic centimeter. So if you were to report this as your final answer on a quiz, you actually would be marked wrong because it's specifically asking for the density in grams per cubic centimeter. So my final answer should be written like this. There we go. What would you expect to happen if the cup of olive oil in question 6 is poured into a container of ethanol, and why? Well, on the first page, we talked about whether substance A or B would float or sink in water, and we talked about how things that are more dense will sink to the bottom, and things that are less dense will float to the top. So we need to compare our densities of olive oil and ethanol. So let's find my density of olive oil. Here it is. And my density for ethanol is way up here. There's my density of ethanol. And I need to ask myself which one of these numbers is bigger, 0.789 or 0.911. This one is denser. This one has a larger density. Olive oil has a larger density. Which means that if I pour some olive oil into a container of ethanol, the olive oil is going to sink because the olive oil, again, is denser. The olive oil, hope you're okay with that abbreviation, will sink because it is denser than the ethanol. There we go. All right, let's move on to question 8 here. Gold has a density of 19.3 grams per cubic centimeter. A cube of gold measures 4.23 centimeters on each edge. And it wants to know what is the volume of the cube. Well, they just told us the dimensions of the cube, so 8 isn't even a chemistry problem. It's not even a density problem. This is just geometry. So let's draw our cube again. Let's draw our cube again. That's a pretty good cube. And this time we know that it's not 2 centimeters on each side, but 4.23. 4.23 by 4.23 by 4.23. Our volume, again, is length times width times height, or side cubed. So I'm going to say 4.23 centimeters times 4.23 centimeters times 4.23 centimeters. I'm going to get my calculator out, and I'm going to say 4.23 times 4.23 times 4.23. And I get 75.69 cubic centimeters is my unit for volume here. And there we go, that's our answer. No density needed here, just 75.69. We do not need 19.3 grams per cubic centimeter to get this question. I know it's a little bit annoying, but I mean, in fairness, it does give us that information before it asks what is the volume of the cube. You know, so this isn't actually part of number 8. This is just information about gold. In 9 now, we do need the density, right? So this information goes with 8, 9, and 10. Now it's asking us what is the mass of this cube, right? It's asking about that. Well, we know the volume of this cube, right? We know that it has 75.69 cubic centimeters. We want to know the number of grams that goes with 75.69 cubic centimeters. Well, what do we know about gold? We know its density, right? We know that the density of gold is 19.3 grams for every 1 cubic centimeter. Again, just to point this out, I lined up my G with my G and my cubic centimeter with my cubic centimeter. Well, now I need to ask myself, I need to find where my question mark is, look across the equal sign to the other number, to its partner. 75.69 cubic centimeters. Is this larger than or smaller than the number above it? It's larger than. How many times larger is it? Hopefully we should be able to see that it is 75.69 times as many cubic centimeters on the bottom as there are on the top. If we have 75.69 times as many cubic centimeters, then we should also have 75.69 times as many grams. So to figure out our number here, we're going to say 19.3 grams times 75.69 times as many grams equals our number here, our answer. So I'm going to get my calculator. I'm going to say 75.69 times 19.3. And I get 1460.8. 1460.8 grams. That is the mass of this cube. It asks us about significant figures here. I don't really care. I'm just going to report my answer like this. We might talk about significant figures later. Probably not, honestly. I don't really care about it that much. All right, last question. A standard backpack is approximately 30 centimeters by 30 centimeters by 40 centimeters. Suppose you find a hoard of pure gold while treasure hunting in the wilderness. That's incredible. How much mass would your backpack hold if you filled it with the gold? An average student has a mass of 70 kilograms. How do these values compare? All right, so let's draw a picture of our backpack, I guess. Our backpack is going to be roughly, well, I'm going to treat it like it's a cube or a cuboid, even if it's not. Let's put a handle on there and some straps. There we go, that's backpack-ish. We know the dimensions of our backpack, right? It is 30 by 30 by 40. So I'm going to say 30 by 30 by 40. We're going to treat this like it is a rectangular prism. So to figure out the volume, I'm going to go length times width times height. So I'm going to say 30 centimeters times 30 centimeters times 40 centimeters. This will give us the volume of our backpack. When I do that math, I get 36,000 cubic centimeters. That is the number of cubic centimeters that could fit inside our backpack. So if you can imagine drawing all these little cubic centimeters in there, I could fit 36,000 of them. So how much gold could we put in there? Well, we could put 36,000 cubic centimeters of gold in my backpack then, right? If this is the number of cubic centimeters that fit, I can fit 36,000. All right, so we want to know how much mass would that be? Okay, well, what do we know about gold? I remember that our density is 19.3 grams for every 1 cubic centimeter. I'm going to start my problem that way. That's my setup, the conversion factor that we know. And now we need to know the mass, the number of grams that goes with not 1 cubic centimeter, but 36,000 of them. So I'm going to find my question mark. I'm going to go across the equal sign to find this number, 36,000. I'm going to ask myself, is it bigger than or smaller than the number above it? It is clearly bigger than 1, 36,000 is. And how many times bigger is it? It's 36,000 times bigger. So we have 36,000 times as many cubic centimeters on the bottom as we do on the top, which means that we should also have 36,000 times as many grams. So to figure out what that number is for the question mark, I'm going to go 19.3 grams times 36,000 times as many grams. I'll get my calculator out and I'll say 19.3 times 36,000, and I get 694,800 grams of gold is the mass of 36,000 cubic centimeters of gold. All right, that's how much mass my backpack would hold if I filled it with gold. If I fit as many cubic centimeters as I possibly could in my backpack. The average student has a mass of 70 kilograms. How many grams are in 70 kilograms? Well, we should know, or we might know, I hope you would know, that there are 1,000 grams in 1 kilogram. I know you learned that at some point. It's okay if you don't remember it. But now you know, I guess. 1,000 grams is equal to 1 kilogram. As we go further into the year, you will see this a bunch of times, I guess. So you'll know it eventually. 1,000 grams is equal to 1 kilogram. So how many kilograms is equal to not 36, but 694,800 grams. Right, now you see what I mean by this math is everywhere. Right now we're not even doing density anymore. This is just metric conversions. But I need to ask myself, okay, I'm going to find my question mark. I'm going to go across the equal sign and find this number. Is 694,800 bigger than or smaller than 1,000? It is clearly bigger than. How many times bigger is it? What do I need to multiply 1,000 by to get to 694,800? 694.8 is the number of times. All right, so if I have 694.8 times as many grams on my left, I should also have 694.8 times as many kilograms on my right. So to figure out what this question mark is, I'm going to say 1 times 694.8 equals 694.8 kilograms is the number of kilograms that I could fit, the number of kilograms of gold that I could fit in my backpack. So how does 694 compare to 70, which is the mass of a student? Right, this is my gold. This is a student. 694 is clearly much, much bigger. How many times bigger is it? Well, it's about 10 times bigger. Or, if you prefer, I prefer, about 10 times heavier. So imagine that, a backpack that weighs 10 times the mass of you, the mass of a student, 70 kilograms. That's incredible. That shows us just how dense gold really is. Yeah, way, way, way denser than you are. And there we go. This gives us our answer. I hope that this was helpful. If you have watched all of this and you are still confused, watch it again. And then if you're confused after that, come see me. Because this math, this kind of math, you need to get this down. Some of it is, like this is not super necessary, right? This is geometry, this isn't even chemistry, but it is a kind of abstract thinking that we do need to get better at as the year goes, right? And this one, number 6, is, I guess, harder than density problems that you'll see on your quiz and on any test that you might take, but this is a great way to tell that you are getting it, right? These aren't great assessment questions, but they are really good practice questions. And so I want you to understand these. I'm not going to make a video for this page. If you need more practice, come see me if you don't have this page already, and you can get, I can get you this last page. It'll really help with your math, yeah. And if you are worried about math, definitely do this page or try this page, and then come see me in reteach or before or after school anytime, and we can talk about it. All right, that's it for me.